morning, students. Chapter 4, Moving Charges and Magnetism. In last lecture we have discussed what is moving coil galvanometer. What is moving coil galvanometer? Okay, what is its function? Yes, when current flows from coil, that coil is placed in uniform radial magnetic field. So in magnetic field it rotates. Attached with it there is one pointer. So pointer also rotates on circular scale. And that deflection is directly proportional to current. That we have obtained one equation. Okay, that phi is equal to d sin A upon k into I. Okay, so yes, deflection depends on current. So galvanometer is used to measure voltage and current that we have discussed. But there are some difficulties to directly use galvanometer as current measuring instrument, as voltage measuring instrument. Here, what we have to do? See, if we want to measure current, then we have to connect current measuring instrument in series with that load. In series with that load. Okay, see, here it is. To measure current, current measuring device, to measure current, device is connected, device is connected in series with that load, in series with that load. Clear? Now if we use galvanometer as current measuring instrument, if we use galvanometer as current measuring device, current measuring instrument. Okay, then what happens? See, it is resistance R, for example. Okay, I want to find what is current flowing from this resistance. Then obviously, to measure current, device is connected in a series with that load. So we have to connect galvanometer in series. We have to connect galvanometer in series. Yes or no? Yes, it is. So, what is problem here? When galvanometer is connected in series with that load from which we have to find what is current, there are two problems. Okay, there are two problems. Which two problems? First, see, as this resistance means load and galvanometer, they are in series connection. Galvanometer having some resistance G. G is resistance of galvanometer. Resistance of galvanometer. Okay, so see here, as this resistance and galvanometer, they are in series connection, and we know that in series connection equivalent resistance is larger than largest. So first problem is resultant resistance changes. Now if total resistance changes, then obviously this current I also changes. Initially we have only this circuit, only resistance R, then current flowing is I. Now if I add galvanometer, then obviously resistance of connection increases, then this current I decreases. Then yes, current to be measured changes. Clear about this? Okay. So second problem. What is second problem? Second problem is galvanometer. Yes, moving coil galvanometer. What is construction of moving coil galvanometer? In galvanometer there is one coil, and yes, that coil is sensitive. Okay, coil in galvanometer is sensitive. Why sensitive? because we know that it is conductor. And in conductor, if current is flowing, then according to I square RT, joule heat is produced. According to I square RT, joule heat is produced. Okay, so when in coil current is flowing, according to I square RT, according to I square RT, joule heat is produced. Joule heat is produced. Okay, then there are chances to damage coil. There are chances to damage coil. Clear about this? Okay, if from galvanometer more current is flowing, okay, value of current is larger, then obviously according to this I square RT, joule heat is produced, and yes, there are chances, okay, that the coil is born. Clear about this? So yes, when we use galvanometer directly as current measuring instrument, we have two problems. First, resultant resistance changes, so current to be measured also changes. Second, coil in galvanometer is sensitive, so according to I square RT, joule heat is produced, and yes, there are damage to coil. Okay. Also, galvanometers are sensitive. Galvanometer is a sensitive device. Sensitive device means for small value of current. It shows full scale deflection. Now what is meaning of full scale deflection? See, if you have observed circular scale like this, okay, here it is 0 and these are calibrations. Okay, so what is meaning of full scale deflection? Initially pointer is at 0. Now if very small amount of current flows, then this pointer moves from this to this maximum limit. So yes, it is called full scale deflection. For very small value of current. So if current is greater than this much amount of current, then obviously there are chances that this coil is damaged. Okay, and the value of current for which it shows full scale deflection, it is called current capacity. Ig. See, value of current for which galvanometer shows full scale deflection. Shows full scale deflection is called current capacity Ig. Clear about this? If I say, okay, for galvanometer current capacity is 5 milliampere, then what is meaning of 5 milliampere? If current flowing from galvanometer is 5 milliampere, it will show full deflection. Clear? So yes, galvanometer is sensitive device. For small value of current, it shows full scale deflection. Means it is not used to measure large current. Yes or no? Yes. Or current flowing from this galvanometer should be limited or very small. Then how to resolve such problems? From this it is clear that we cannot use only galvanometer to measure current. And to solve such problems, what is solution? See, here it is. Resistance, galvanometer, okay. Resistance of this resistor is I, R. Current flowing from here, it is I. Galvanometer's resistance is G, similar to this, okay. To resolve this problem, we have to connect a resistance having very small resistance in parallel with galvanometer. with this galvanometer in parallel, I connect a resistor having very small value of resistance, and yes, resistor having very small value of resistance is called shunt. Clear about this? Okay, so yes, what we have to do, connect shunt. Shunt means very small resistance, parallel to galvanometer. So what happens? See, what about these problems? What is first problem? Resultant resistance changes, current to be measured changes. Now, if you connect this shunt parallel to this galvanometer, shunt, very small resistance, yes or no? Yes or no? Yes. So you know that in parallel connection, equivalent resistance is smaller than smallest. If its resistance is 0.05, okay, 0.05, then equivalent resistance will be smaller than 0.05. Yes or no? So yes, if we connect very small resistance, that is shunt in parallel, overall resistance of this decreases. And if I am taking value of shunt very small, then this resistance becomes nearly zero. Then obviously, initially resistance is R. If we connect only galvanometer, then R plus G, resistance changes, current to be measured changes. But now in this case, it is R plus its resistance. Its resistance is almost or near to zero. It's tend to zero. Clear about this? Then no changes resistance means current to be measured will be right. Clear about this? So first problem is solved. What is second problem? See, coil in galvanometer is sensitive according to I square RT, joule heat is produced. So from galvanometer only Ig current must be flowing. Yes or no? And yes, it will flow. Galvanometer, it is shunt having very small value of resistance. It means current is flowing more when resistance is small. Yes, I is equal to V upon R. So from this current I, only Ig current is flowing from galvanometer, and most of current, that is I minus Ig, will flow from shunt. Most of current will flow from shunt because its resistance is very small. So see, when from galvanometer current is flowing up to its current capacity, up to its current limit, then according to I square RT, no more joule heat will produce. There is no damage of coil. Clear about this? So yes, these two problems are solved. So here, what is conclusion? Galvanometer itself, only galvanometer, is not used as current measuring instrument. Galvanometer along with this shunt in parallel is used as current measuring instrument. And yes, this circuit, galvanometer and shunt, their parallel connection, it is called ammeter. Clear about this? Parallel connection of galvanometer and shunt, it is called ammeter. And see, this ammeter, what is resistance of ammeter? It is very small. For ideal ammeter, its resistance is 0. So here parallel connection of G and S. What is G? Resistance of galvanometer. What is S? Shunt. Is called ammeter. What is resistance of ammeter? Resistance of ammeter is very small. resistance of ammeter is very small. And if I am talking about ideal ammeter, if I am talking about ideal ammeter, then for ideal ammeter, its resistance is 0. Its resistance is 0. Clear about this? Okay. So now I can draw this figure like this. See, resistance, it is ammeter. Okay, current flowing is I, its resistance is R. And yes, here it is ammeter, it is symbol of ammeter. Clear about this? So what is ammeter? Ammeter is parallel connection of galvanometer and shunt. Shunt means very small value of resistance. Now question, sir, how current Ig is flowing from this galvanometer? For that, we have to decide a proper value of shunt. A proper value of shunt. So how to find this value of shunt? What is equation of shunt? That we will see. Now how to find value of shunt? See this figure. Current I is flowing from this resistance. From galvanometer, only current of its capacity, that is Ig, will flow, and another current will flow from this shunt. See, this G and shunt, they are in parallel connection. Then how to find value of shunt? How to find shunt? Okay, see, these two are in parallel connection. So in parallel connection, potential difference remains same. Yes or no? For this, between these 2 points, potential difference, resistance into current means GIG. Yes or no? It is GIG is equal to, what is potential difference between these 2 ends? S means it is resistance and current flowing is I minus Ig. Then yes, it is SI minus Ig. Then make S as subject. S is equal to, it is GIG upon I minus Ig. GIG upon I minus Ig, where what is G? G means resistance of galvanometer. Resistance of galvanometer. Resistance of galvanometer. What is Ig? What is Ig? Ig means current capacity of galvanometer, or maximum current flowing from galvanometer, or current flowing when there is maximum deflection. So this current capacity. It is current capacity. What is I? I is current to be measured. I is current to be measured. I means current to be measured. Clear about this? Okay. So yes, it is equation of shunt. S is equal to, it is GIG upon I minus Ig. Now, in the last lecture, we have obtained one equation, that is K phi is equal to NIAB. NIAB. If I make phi upon I as subject, phi upon I, then phi upon I is, here it is NAB upon K. This phi upon I, that is deflection per unit current. Deflection per unit current. Phi upon I is deflection per unit current. Per unit current is called current sensitivity. Is called current sensitivity. Clear about this? Clear about this? So yes, how to find value of shunt? S is equal to GIG upon I minus Ig. Phi upon I, that is NAB upon K, is called deflection per current, per unit current, and it is called current sensitivity. So it is how we can convert galvanometer in ammeter. To convert galvanometer in ammeter, we have to connect a shunt parallel to galvanometer, and this whole system is called ammeter. What is resistance of ammeter? Very small. For ideal ammeter, it is 0. For ideal ammeter, it is 0. Clear about this? Now next theory, we will see how to measure voltage or potential difference, and what is voltmeter and what is voltmeter. Okay. Now voltmeter measures potential difference between 2 ends of a load. Load means resistance. Okay. So yes, we know that to measure current. Current measuring instrument, current measuring device is connected in series, because we know chapter 3, in series connection current is same. That's why current measuring instrument is connected in series. And now how to measure potential difference? In which connection potential difference is same? In which connection potential difference is same? Yes, parallel connection. So to measure potential difference across a load, voltage or potential difference or voltage measuring instrument is connected in parallel. So first statement that you have to write here, it is to measure potential difference, device is connected in parallel with load. Clear about this? Okay. If I have this resistance, and I want to find what is potential difference between its two ends. What is potential difference between its two ends? Okay? Okay? Yes. Current flowing is here, it is. I want to find what is potential difference between its two ends. Then obviously I have to connect a device parallel to it. So yes, I have connected this galvanometer. Okay, let galvanometer meter is connected. Galvanometer is connected parallel to load. Again, when galvanometer is connected to parallel to load, again two problems. Resistance of circuit changes, current changes, then potential difference also changes. Yes or no? Yes, it is. Again, galvanometer is a sensitive device. So for very small value of current, it shows full scale deflection. Means from this galvanometer, only IG current should have to flow. Clear about this? Okay. So again, we cannot use galvanometer as voltmeter or to measure potential difference. Okay. Again, there are two problems. Clear about this? Now, how to solve such two problems? From this galvanometer, only IG current must be flow. Only IG current. Then how it is possible? Okay, two problems are there. First, resistance changes. See, R and G, they are in parallel connection. So obviously, equivalent resistance changes. Yes or no? Equivalent resistance changes. Yes or no? Yes, it is. Okay, so this current I also changes. Because this I is distributed in two parts. So what is solution? Solution of this is connect a large series resistance with galvanometer. Then see how to draw figure. It is resistance R, current flowing from it is I. Yes, here it is galvanometer, and we have to connect one series resistance with galvanometer having value Rs. What is value of this galvanometer's resistance? It is G. Clear about this? Then what happens? See, each and every problem they are solved. Here. G and S, it is large resistance, means they are in series connection. Yes or no? Yes, they are in series connection. Okay? Clear about this? Okay. G and RS, series connection means equivalent resistance is greater than greatest. So obviously, if resistance of this circuit is large, resistance is very large, then obviously current flowing from this it will be very, very small. Only IG current will flow. Yes or no? Yes. Okay. Okay, so yes, all two problems they are solved. All two problems they are solved. What you have to do? You have to connect one series resistance with series, in series with galvanometer. And yes, this series connection is called voltmeter. This series connection is called voltmeter. Okay, the series connection of galvanometer and series resistance RS is called voltmeter. Clear about this? Okay, what is resistance of voltmeter? The resistance of voltmeter is very large. What is resistance of ideal voltmeter? Resistance of ideal voltmeter is infinite. Clear about this? How to draw this figure? Like this. It is resistance, and yes, here it is voltmeter. Okay, current I, here it is R, and here it is voltmeter. Okay, so yes, voltmeter means series connection of galvanometer and resistance. Now again, how to find value of this RS? Okay, then how to find? See, here it is. From this figure, what we have to find? We have to find what is potential difference between these two ends. I am assuming potential difference between these two ends of resistance is V. Yes or no? Yes, it is. Let's see how to find it. Potential difference between two ends of resistor. Is V. Then how to measure this value of V? See, potential difference between these two and V is equal to, what is potential difference between these two and what is total resistance? Total resistance is G plus RS, and what is current? It is IG. Clear about this? Total resistance is G plus RS, and what is current? IG. So now it is V upon IG is equal to G plus RS. So RS is equal to, it is V upon IG minus G. So it is equation of RS. RS is series resistance, I is current capacity, G is galvanometer's resistance, and V is potential difference to be measured. Clear about this? Okay, so yes, it is all about voltmeter. Now, see, phi upon V means deflection per unit voltage. Deflection per unit voltage. Potential difference is called voltage sensitivity. What is its equation? Yes, you have to find phi upon V. So I can write this phi upon V is equal to, what is V is equal to? Yes, phi upon V. We know that V is equal to, it is IR. So yes, V is equal to IR. Now phi upon I, just below what is phi upon I? We have obtained, see, A phi is equal to NIAB. What is phi upon I? Phi upon I is NAB upon K. So yes, phi upon I is NAB upon K, and here it is R. Clear? So it is equation of voltage sensitivity. Clear? Ammeter is parallel connection of galvanometer and shunt. Shunt means very small resistance. Voltmeter means series connection of galvanometer and series resistance having large resistance. So what is difference between them? Ammeter having very small value of resistance. Voltmeter having large value of resistance. Ammeter, ideal ammeter, resistance 0. Ideal voltmeter, resistance infinite. infinite. Clear about this? Ammeter is connected in series. Voltmeter is connected in parallel. So if you are asked difference, you can write such points. Clear about this? So in today's lecture, we have discussed about how to convert galvanometer in ammeter and voltmeter. Okay, watch regular videos, make notes, send your notes. Okay, and yes, you have also solved MCQs given by teachers in group. Okay, and yes, do like, share and comment our videos.